Okay, so we're going to just do a quick review here of the translations, putting all the transformations or possible transformations together. And we had an equation that looked something like this. The tricky one is probably the A. Remember, that's going to do a stretch or compression. If the absolute value of A is greater than 1, it's going to be a stretch. And if the absolute value of A is between 1 and 0, it's going to be a compression. And if A, the actual value of A, is negative, less than 0, it's going to reflect about the x-axis. So A tells us a lot. We assume the parent function, g of x, is the parent function. And that would just be log base b of x. So that's how you would get the parent function. C is going to tell you a horizontal shift. Let me make it a colon. Horizontal shift. If C is positive, then it's shifting left. Yeah, and if C is less than 0, it shifts right. Okay, D is the vertical shift. And if D is greater than 0, it shifts up. And if D is less than 0, it shifts down. Now, one thing that we kind of left out, but if the parent function is f of x equals log base b of the opposite of x, that reflects about the y-axis. We'll just throw that in. We don't want to leave that out because we did do one like that. Okay, so now we're going to look at this function we have here. And it says, what is the vertical asymptote? So the question doesn't really ask us to graph it. We could graph the parent function. The parent function would be log base 3 of x. And you could make a little table of values. You could write it as 3 to the y equals x, and plug in things like -1, 0, 1, 2. And then you'd get like 1/3, 1, 3, and 9. So I don't think it's a bad idea to review how to graph those parent functions, since we've just started with the logarithm functions, and how to do that. So we get a point there, we get one here, we get one here, and we get one here. Okay, so that's our parent function. And it gives us a nice picture. And now we can graph the f of x. And we can do that by doing the transformations on it. So we know it's going to reflect upside down. So -2, it's going to have a stretch. And it's going to reflect about the x-axis. And we know it's going to shift 4 to the left and 5 up. Now, the 5 up, that's not going to make a huge difference for us, but anyway, we'll try to do this. So if I were to take the parent function and multiply that by -2, so it'd be, let's see, -2/3, right? Let's see, make sure I'm doing this right. Put in 1/3 and I would get +2. Okay, so 1/3 +2 would be like up here. This is just going to show the stretch and the reflection. I'm just doing this part right now. Okay. And then that would still go through there, and then I'd multiply by the 1 by -2, so it'd be down there, and then I'd have like -4 down here. So you're going to see the stretch on it. Okay. It's not a huge stretch because it's just a 2 that we're stretching it by. But it does make it reflect about the x-axis. Now we want to shift it 4 units to the left. Well, that's going to change things. So if you move it 1, 2, 3, 4, you're going to have a point there, and then you're going to have a point 1, 2, 3, 4 there, and then you're going to have a point 1, 2, 3, 4. And I should be doing this in a different color so you can see it. So, not drawn very well, but there's kind of the shape of it. Oh, I missed the 1 point, didn't I? That's why. 1, 2, 3. Should have gone through that point. Should have been a little bit steeper there. Okay, but what really matters here, not so much my drawing, but what really matters is, well, my drawing matters a little bit, was the asymptote. The asymptote was shifted over here. Sorry, it's in green. And then it looks like that. But this asymptote's what's going to matter because they asked us to identify the vertical asymptote. They didn't actually ask us to graph this. I was just throwing it in just so you could see it. And then to finish it off, you would move everything up 5 units. So 1, 2, 3, 4, 5. Like if you really wanted to see what the graph looked like. And then 1, 2, 3, 4, 5. And then that last point. So it's kind of, I got a lot of graphs on one thing here. Okay, but it's doing something like that. And that's the actual graph right there, f of x. But all those others were just steps to get there. So we were just, I do the stretch first and the reflection so I can get the shape of the curve. Then I shifted it horizontally, and then finally I shifted it vertically. Okay, but they didn't ask us to graph it. They just said, what's the vertical asymptote? Vertical asymptote is x equals -4. So more than you wanted to know, but good review of transformations.